So in this very first thing, I didn't really give it to you in any of these formats here, but can you see how it kind of goes along with when I set up here 1 goes to 4 and it goes to 3? Oh, good. So like what does 5 go to? What does an input of 5 give you as an output? 3. So far so good. Does 5 go to anything else? No. So you can see the D and the R, that's domain and range up there, right? Domain, range. 6 only goes to 3. And 8 only goes to 2. So there are no X's that have more than one Y. No inputs that go to more than one output. Therefore, is this a function?
Yes.
Yes. Don't freak out that both of these go to 3. I don't care, right? I can have one ball that's at a height of 3 and another ball that's at a height of 3. That's fine. For 2 different inputs, I can have the same output. That's fine. So it's okay that they both go to 3. It's just that no X can go to more than one Y. So you can see part B. What is it that tells you the answer pretty quickly there? Yeah, the 5 is trying to go to 3 and it's trying to go to 2. So it's sort of like I ask person number 5, how many TVs do you have in your house? Well, I have 3 and 2. What the hell drugs are you on? Do you see what I'm saying? I mean, that's exactly the idea with a function. You can't ask one question about something and have somebody give you 2 different outputs. What size shoe you're wearing on the left foot? You can't be wearing 2 different size shoes on the left foot yet.
So because the 5 goes to, on the second one?
Yeah, so an input goes to more than one output. So this is not a function. Okay. You don't have to be as emphatic as I am. Not a function. So these, we've seen this form before. What is it about part C that tells me the answer? Yeah, one quick, one shortcut there is when I give you points, you just look for an X value that's repeated. So 9 goes to 1, but then it also goes to -5. So you say not a function. 9 goes to 1 and -5.
Do you want us to write that? The 9?
Yeah, the why or why not, I really should be doing that too. So over here, this is not a function because of this.
Can we just circle? So
That's fine.
Domain is X and range is Y.
I like it.
That's easier.
What about?
So if there's 2 X's going to, I'm sorry, if there's 1 X going to 2 different places.
That's a bad thing. Yeah, that's not a function. It's not a bad thing, it's just not a function. What about part D, is that all right? Yeah, 2 only goes to 1, 3 only goes to -5, 9 only goes to -5. I don't care that these 2 both go to -5. Who cares? They each only have one thing. Therefore, this is, yes. No X goes to more than one Y. If you want to have the official Y. Well, no X goes to more than one Y. How are we doing so far? Yes, yes, yes. Okay. So here's the visual. And the visual is kind of nice because it's a really nice, easy test. You can see anything that fails pretty obviously. So what about E? Does it pass or fail? Fails. There's a vertical line I can draw, and it goes through more than once. Now there is a vertical line I can draw right here that only goes through once. But the vertical line test says if there's at least one vertical line goes through more than once, that means that that X has more than one output. Not a function. Now, I want to really quickly make a point here. That doesn't mean that circles are bad. That doesn't mean that circles can't be used in other ways. That doesn't mean anything. But that couldn't possibly represent, I couldn't say at 2 seconds, where is he? He's up there and he's down there. That doesn't make sense. So functions are just a category of things that could immediately be used for real life graphs. What about F? Yeah, I can't see any vertical lines that I could draw that would go through more than once. So it passes, yes, function. Cool. All right, so far so good? Okay. So here's the other main thing about functions, and this is actually the biggie. This is the one that this kind of, you do this for a little while, and then you really don't see any problems like this anymore, just this kind of to introduce the idea of function. What you see in mathematics a lot after this point is stuff that look like this. f of x, g of x, h of x, c of x for a cost function, whatever, right? So this step here is most important if you wanted to try to prioritize this. And the mistakes people make on this. Here's one mistake people make. First off, how do you read this?
X equals negative 1.
Yeah, so you would read this f of negative 1. Or you could even say f at negative 1 in a way.
What does that mean?
What that means is it's exactly like, how do you read this? Just read that. Don't tell me what the answer is. Read it.
Square root
Say it slower.
Square root of 49.
Of. Cool. So the square root is a function. So the square root of 49. Here, if I just write f, do you know what that is? Is this a square root? I don't know, but it's still f of x, just like this is square root of 49. Because the 49 is the input, like the x is the input. Do you guys see the connection? A little bit. Well, it's better than not.
So the square root is a function because
The square root is actually a function because you'll learn next semester the square root looks like this. It looks like a parabola that fell over and lost its bottom half. So like the square root of 1 is what? Square root of 1 is 1. Square root of 0 is 0. Square root of 4 is 2. Do you see how it takes that shape?
okay.
And does that pass the test?
Sure.
It's going to keep going that way forever. There's no vertical line that goes through more than one, so that is a function.
Okay.
So that's the kind of thing you're going to do. As you get to the next level of math, you're going to learn more functions, more equations, and you're going to identify which ones are functions and
Now
so
we're
forth.
gonna do like the loop graphs and stuff.
Oh yeah.
Yeah. I remember
Okay.
that in high school.
So that's how you read it. And if you can't read it, that's okay. But it's kind of important to be able to read that. So that's f of negative 1. Now, what's more important, really, what's more immediately important is how the hell do you do that problem?
Will you fill in
Which function am I going to use?
the 2x minus 1?
Yeah, because that's f, right? If I want h of 3, that's going to point me to this guy. So that's one of those reasons why we invented this idea of functional notation, is so I can identify which thing to use quicker. So f of negative 1, f of x is 2x minus 1, so f of negative 1 must be twice negative 1 minus 1. All you do is you plug this in. You plug it in. So the point I was trying to make the other day, let me let you guys copy that down. We're obviously not done with that, but the point I was trying to make the other day, do you remember we had a problem like almost exactly like this before? And I said, evaluate this when x is 2, y is negative 3, z is 5, right? Remember those kind of problems? And at this point in the semester, those kind of problems should be like, oh yes, Jeff. Put a lot of those. And I'm not, but that's all right, I might put one. Well, what's the idea here? How do you do it?
You plug it in.
You plug a 2 in there, you plug a what there?
Negative 3.
So forth. So there's nothing new here. The f just tells me which one to look at, and the number inside just tells me what to put in. So it's just a substitution. Don't make it more than that. So f of negative 1 is, what do I get?
Negative 3.
Yeah, negative 2 minus 1 is negative 3. You just do it. 2 times negative 1 is negative 2. Minus 1 is, just do it. Just do what it says to do. Now the mistake, now you ready? That's done. You stop there.
Oh, that's as far as you go.
Yes. Here's a mistake people make.
Or do they make it negative f, like I said?
Sort of. Well, maybe. That's actually a creative twist on this. The mistake people make is I'll see somebody do this next step somehow.
Yeah.
Oh, because I want to just.
Okay. No. This is not f times negative 1. That is f of negative 1. So a real quick example to show how silly that is. Square root of 7 equals x, let's say, right? Because I don't know what it is. Could I divide both sides by square root symbol and get rid of it? Or could I divide both sides by 7 and just get in there and get rid of it? No, I can't. I can't do that. So these go together. That is f of negative 1. Or another way to think of it is, what is the function when the input is negative 1? It is negative 3. So let me ask you right now, can you tell me a point that this function goes through if I were to graph it? What's a point that it goes through? -1, comma, -3. When the input's -1, the output is -3. There you go. See, that's another kind of advantage for this. I can see the whole point right there. Okay. All right, here we go. So how do you do h of 3? Which function am I using there? Yeah, the h one. So if h of x is x squared minus 1, h of 3 must be 3 squared minus 1. Again, it's just substitution. Don't make it any more than that. And what do you get when you do 3 squared? 9 minus 1 is 8. So what point do I know that h goes through? 3 comma 8. When x is 3, the output y is 8. Yes, ma'am?
I was just gonna ask about what you are looking at next one.
Yeah, we're coming up on that one.
So do you want the coordinates?
Well, that's kind of like a side question I'm asking. But, I mean, to tell you honestly, I know I keep flipping back and forth, but remember when we first did graphing lines?
Yeah.
What's the very first way to graph something? Make an XY table. Right? So you'd plug in a 2, and out would come 6 plus 7, 13. Right? So it'd go through the point 2, 13. So what does it look like now? Now I can say f of x is 3x plus 7. So I can say f of 2. So plug in a 2.
Okay.
So f of 2 is 13.
That's it.
So I can see the point there.
It's the same thing.
And I can do f of 5 is, or f of -1 is, and I can see the points in the work. So I don't have to make like a separate XY table. And that's not the reason that functions were created, but that's kind of an offshoot of how useful they are. Okay, so g of 1. Where would I put that? Yeah, this guy, the ratio, right? So g of 1, g of x is x minus 1 over x plus 5. So g of 1 is 1 minus 1 over 1 plus 5.
Or plus 5.
So wherever there's an x, you replace it with 1. We doing okay? And of course, what's 1 minus 1?
Negative
0 over, I like that. 6 and 0 over 6 is? 0. Not undefined.
That's if the zero's on the bottom.
If the zero's on the bottom, it's undefined, exactly.
Oh, okay.
That's coming up. So here's the cool thing. Look at this. This looks like it's going to be hard. H of x is x squared minus 1. So what's h of m?
M squared minus.
M squared minus 1. It's even nicer because can you go any further?
No.
I don't know what the hell m squared is. I'm done. So that kind of points to the fact that what's so special about the letter x? I don't know. I wasn't around when they picked it. They all just said, let's use x. And the one guy that said, let's use a, they kicked him out of the room, and then they just kept using x. So they could have used m. And he got over it. He's all right. They could have used m. They could have used a. They could have used y. If I just say h of y, that's y squared minus 1. Are you guys semi with me?
Mm-hmm.
Just to show you what kind of like the next level could look like, if h of x, yeah, this back looks disgusting as well. If h of x is x squared minus 1, can somebody have any idea of what h of y plus 7?
Y plus 7 squared minus.
Yeah, you don't even have to think. You just put that sucker in there, and then you could foil it and do all that kind of crap to it. You with me?
Oh, is that what?
Whatever the hell's in there. What's h of Amy?
Oh,
Amy.
Amy squared minus 1.
Okay.
You can handle
I
me
get it.
squared.
Yeah, yeah. H of whatever is whatever squared minus 1. What's h of box?
Box squared.
Box squared minus 1. Alright.
Square.
Sim squared.
So that's h of m.
Did you want undefined for G? G?
No.
Is it undefined?
Where are we at?
Is
Well,
G-
now we're doing part E. Yeah.
That's what.
So the domain of g of x. What does domain mean again?
X.
What about x?
I don't know.
All the x's that you're allowed to put in, right? All the allowable inputs. You with me? That's what the domain means. The range is all of the outputs that come out. The range is all the inputs you're allowed to use. Did I just say that backwards?
I think you're dead.
The domain is all the inputs you're allowed to use, and the range is all the outputs that come out. Okay. Domain goes with X inputs, range goes with Y outputs. It's been a long day. So when you look at g of x, here's g of x. Let me write it again because it's kind of getting lost. Can you tell me, what about that function tells me that there's a trouble spot possibly? What kind of function is that? What kind of number would come out if I put some number in there?
A 0 could come out the bottom.
Yeah, it's a fraction. It's got a bottom, and the bottom can't be 0. So the bottom can't be 0. So this is not something new, right? I'm using the word domain, but it's exactly the same as the problems that said, what x's can you not use? Well, then all the x's you can use is called the domain. So x can't be -5, you're right. So the domain officially would be all reals except -5. I can almost spell. Wow, Jeff.
We know what you mean.
I have an extra letter in there.
Wait.
Except.
So, because, like, since the top was 0, what if the top isn't 0? Like,
The top I don't care about, do I?
no, I guess not.
The top could
Just
be
like
anything
C.
it wants to be. The only thing that cannot happen in a fraction is the bottom can't be 0. So you can actually completely ignore the top.
Okay.
Because the only thing that tells me there's a problem is if the bottom is 0. The top can be 0, the top can be whatever it wants to be. Okay. Now here's the one that freaks people out, but I think I'm running out of space on the back of this one. Let me see. Let me ask you this here. If I give you a function, x minus 1, and you do f of 3, what do you get? 2. I love it. So can you start to plot this out? What do you know so far?
There's a point of 3 and y is 2.
When x is 3,
Y is
y is 2. So what point does this go through? The point
2.
3, 2. So 3, 2, there's a point. So we put that point right there because when x is 3, the output is 2. That's why we put a point there, right? So the problem people have with this problem here is when I say what's f of 2, people say, well, what the hell is f? You gave me f up here, but I don't know what f is on this problem. So how can I figure that out? And I'm saying somebody's already done all the work for you. They put f of 2, that means what is 2?
Y is 6.
Well, take a step back. What is 2?
X.
X. So when x is 2, now look at when x is 2. Where did they put the point? Right there. Yeah, so the point 2, 6. So you're just really completing that point. When x is 2, the output is 6. So what's f of 0, for example?
-2.
Yeah, when x is 0, the output is -2. There, see? F of 0 must be -2 because when x is 0, the graph is at -2. Do you guys see that?
Did you find 6 because you were able to look at the graph?
Exactly. So I either have to give you the function so you can plug it in, or I have to give you the graph because those are the answers after you've plugged them in, right? So somebody's already did the work for me. One last one. What's f of -3? 1, because that's where it is. The output is 1. So f of -3 is 1 because it goes to the point -3, 1. Okay. And then the last question here, I don't know if you guys remember how to get the domain and the range. Domain is related to x. So to get the domain, you look at the x-axis and you say, what's the first time I see the blue line, the function?
That it crosses on that x? Like you mean the first time it crosses?
No.
The first point.
So I'm walking on it and I'm looking up and down. And here I don't see it anywhere, do I?
No.
First time I see it is at -3. Another way to look at it, if you want to, is which x has an actual output. Does -4 have an output?
There's not.
No, the very first x that has an output is -3. So the domain starts at -3 and it stops where?
2.
That's the last output I have. That's the last time I see it, right? Is at 2. So the domain goes from -3 to 2. Whew. And the range, it has been longer. And the range goes from what to what now? Which? Yeah, -3 is the first time I see an output. Careful now.
Wait.
See, if you say -2, it actually has outputs that are below -2, right? So be careful. Look for the lowest. That's the lowest the output gets is at -3. And the highest the output gets, 6. Okay. So I have a little present for you, since this is disgusting up here and all this stuff. I actually did the little answer key nicer, so you can have this in case you're having trouble tracking your own writing also. Come off of it. Anytime.
Yes, I think so. Yeah, it says so. I feel like I have so much biology to write today. Hopefully I can get at least a couple more questions done. I just feel like I've lost math. I've got like 6.
Okay. So go ahead and give this 2, and then we'll just open up the floor to whatever you guys want to look at. This is the answers to that practice test.
How will we know what grade we get on the final? Will you email it to us?
You will email me, and I will reply.
He's like, I won't reply.
Oh yeah.
Can you check that? Well, I know I only have to know that. I don't know what grade I get on. And then like what my overall grade is. Like what percent. Just because I don't know. Hopefully I can pass over this one. I already get the grade.
My poor camera. What are you doing? That's gonna be a funky video. Oh yeah. Where'd they go? Oh, here. Alright guys, so I am wide open to suggestions on what you want to take a look at, what you want to talk about, what kind of problems you want to work out. Hala?
I just have a real quick question on the practice test 4B. Between the steps of putting it into standard form and the factoring, why did you put X as the GCF and the
Wait, so are we on the practice final or the practice test?
practice test?
So number 4?
No, B.
Number
Number 1.
1. Okay, 1B. Thank you. Oh, practice test 4. That's what's moving on. So.
Did you not put the x squared anymore because you broke it down into the squares right away?
Oh yeah, you're right.
Okay.
I was gonna run out of room, so I kind of did.
Yeah. Okay.
So, on this kind of problem, what tells you what you need to do here? How can I solve this equation?
You have to put it in standard form.
Okay, I didn't really call it standard form, but the main idea is you need to get it equal to
0.
because of that cube, right?
Okay.
Whenever you have a higher power than 1, you try to get it equal to 0. So you subtract that 16x over. And now you just start to factor that. And the one step that I kind of skipped on there, what can come out? And you're left with?
X squared minus x.
And then I just factored that. Yeah.
Okay.
So that's where the x minus 4, x plus 4 comes from on the answer key.
And the other extra stays out. So then for that one, would you make like the x on the outside equals 0
Oh,
or
yeah.
x plus 4, so you have 3 answers?
Exactly. Which makes sense.
Because it
has at most 3 answers, and we will get 3 answers, yeah. So you'd say x equals 0, done with that answer. X plus 4 equals 0, or x plus 4 equals 0. Okay. Yeah.
Possibly a problem with the. I know they stack towards the quiz for one of them, or B.
On the quiz?
But yeah, it's the 2x squared equals 2x plus 25 and
2x squared,
equals 2x plus 25.
2x.
No, x
Or
squared.
x squared.
Yeah, that's more like.
I'm dyslexic, sorry.
That's all right. So, again, you see how this is really the same kind of problem as that one? So what is it? What is telling me to do? What's my first step?
you want to set it equal to 0.
Got to get it equal to 0. And let me tell you, something's going to help you out a lot. When you're moving stuff around, you have a choice of which direction to go. Go in the direction that keeps your variables positive. A lot of you guys did that problem, but you went the wrong way and you weren't sure where to go from there because it looked kind of weird. So I would subtract things this way. Because then see how my x squared will be positive then? Also, some of you guys did this. That would be 50. That's not going to cancel, right? So you got to subtract both of those. So on this side I get 0. On this side I get
2x squared minus
2x squared minus x squared is x squared. And then you just factor and get your answers.
And they would both have to.
Some of you guys left it like this and you thought you had to do something like that. No. These are like terms. That's not, if that was a single x, then you might have to try to factor that like a trinomial, but those are like terms. Don't try to factor till you get everything put together that you can, so you can really see what it is you have.
So why don't the squares cancel out?
Because I'm not dividing. This is 2 times x squared. The only way to kill the x squared is to divide by x squared. Right? When I subtract, I just decrease by coefficient. I had 2 of them, I took 1 of them, now I only have 1 of them. Cool. And that's a really common mistake to make. I see that all the time because our brain says they should go away because we're subtracting. But no, I'm just losing how many of them I've got. Yeah. Hala.
When you're adding, like for example, like 2x plus x, like to the same power, do you add another x to the 2 and make it 3x to the same, or then you add the powers, or is it still 2x even though there's another?
So the weird thing is, that kind of thing, there was no problem until we learned about higher powers and stuff, and then suddenly we had a problem. Because we were doing, this kind of thing way long time ago, almost the first week, right? 2x plus x is just 3x. It can only become x squared by multiplying them. Because exponents are based on multiplication. Coefficients are based on addition.
So you still add the
So this is going to be 3x, yeah.
Yeah.
But if that was 2x times x, it would be
Exactly.
2x
2x times x, 2x squared.
That is.
But you see, I had to make a choice. A choice had to be made in history somewhere. They said, I want to collect a bunch of x's, so I'm going to use the number in the front to keep track of how many x's are adding. I'm going to use the number up here to keep track of how many x's are multiplying. So this is really just the shorthand way of writing this. So some dude was like, I really don't want to write all that shit. So let me just say I have 1, 2, 3, 4, 5, 6, 7, 8. There you go. Let me just do that and tell everybody that's what that means. We all liked it. I wasn't around, thank God. I'm 1,200 years old. We all liked it and said, yeah, sure, we'll do that. Great. And all the properties of exponents come off of this decision. Every property of exponents comes from the fact that the exponents keep track of how many things I'm multiplying. Yeah.
So back to the first one that we were doing, you won't be doing anything. Can't you still do the squares of those two?
Yeah, what's 2x squared minus x squared?
Just
2 of these minus 1 of these is 1 of these. Which is what you know.
Yeah, but don't you still do that for more, like x?
Yeah, and then
minus
you
one?
factor it.
Yeah.
Yeah.
Okay, and then each individual part equal to 0, is that the second
Exactly,
answer?
yeah.
Okay.
I didn't keep going because I got the answers on the answer key, but
So what you combine them.
or not the answer key, but you got to make corrections. I didn't want to do the whole problem for you. Yeah.
Okay. Practice test. You have a 3 number C minus square of minus 16. You say not figure. Okay. Why? If you go on 5, you simplify square of 5 plus square. Multiple square of 10 is square of 50. So why you multiple here and multiple the minus with minus 16?
All right. So here's the idea. If I can multiply 5 times 2, right?
Yes.
And I get 10. So, and they can multiply them because they have the same root, namely no root. So no root times no root, I can do it and there's still no root on the end. So if I had square root of 5 times square root of 2, that would be the square root of 10. They have the same root, I'm allowed to put them together. So if I had 5 square root of 2, can I make that 10 somehow? That doesn't have a root. So they obviously don't have the same root. I can't put that 5 in there somehow magically, right? So this negative here doesn't have a root. Can't go in.
What is the answer to 5 squared?
Here? This. If I said simplify this, that would be a little evil because you're like, what? You can't do it. That's it. There's no way to simplify that.
And then that one, would that be positive squared?
Definitely not. So it's a lot like, can you just bring the negative inside?
No, it's still -7, right?
Well, let me answer my question. Can you bring the negative inside?
No.
Because what do you have to do first?
You have to do.
You have to do the absolute value first. So can you just bring the negative inside? No. What do you have to do first? The square root. Can you? That's why it's not real. You can't do the square root of a negative number. Why not?
Because you can never multiply two numbers negative.
You can't multiply a number by itself and have it come out negative. If the number's negative times negative is positive. If it's positive times positive is positive. It can't ever come out negative. So this is not real. If you wrote can't do, that'd be fine. Because we haven't talked about, and we're not going to, in the next class you will, what imaginary numbers are. So it's kind of hard to figure out what the hell, why you say not real, what's the other piece, you're going to get that next semester. So if you just write here can't do, that's fine. Yeah.
3D.
3D?
Yes.
Okay. Oh yeah. Now, of course, I have a little bit of an advantage in that I'm a little more accustomed to what to look for in these kind of things. Fifth roots are kind of weird. You're like, oh crap. Square roots are easy because you all know the squares. Square root of 64 is 8 because you know 8 square root of 64. Cube roots you kind of know now because we talked about difference of sum of cubes. So like the cube root of 8, you know that that's 2. Cube root of 27, you know that's 3. But fourth roots and fifth roots, that's getting a little bit out of our realm of comfortableness, right? Familiarity. I don't know. Shit. So what you start to do then, you can do something. I knew that 32 was a good number. In general, we don't know that 32 is a good number for a fifth root. We're like, why? I don't know. So you start to break this thing down. And how do you kind of factor this 320? All right, 32 times 10 is the most natural way to do it. Now keep going.
64, 5. Oh.
No. Don't give me another factorization. Keep factoring. Keep factoring. 10 is 5 times 2.
Or 8 and 4.
8 and 4, good. 8, of course, is 3 2s, right? 4 is 2 2s. And then I have times 5 times 2. Now, fifth root needs how many of something?
5.
What do you see 5 of in there?
2.
So the fifth root of this is 2. You with me? Why is the square root of 49 7? Because 49 is 7 times 7. Square root's looking for 2 of something, right? So the fifth root of a number that has 5 2's in it is 2. It's looking for groups of 5, right? So what number is left inside?
5 and 2, 10.
10. So from the very beginning, 32 is 16 times 2, which is 8 times 2 times 2. So 8 is, the cube root of 8 is 2, the fourth root of 16 is 2, the fifth root of 32 is 2, because I just keep adding one more 2 on top of it. Do you kind of see that? Cube root of 8 is 2. Are we all cool? So if I do 8 times 2, now that's 4 2s. So the fourth root of 16 is 2, because it takes 4 2s to make 16. Multiply by 2 again. Fifth root of 32 must be 2, because it takes 5 2s to make 32. But when in doubt, you just break that bad boy down and just see, if it's a sixth root, you look for what is there 6 of. And you take one of them out, and whoever you didn't take out, you leave in there.
But what if you pick something besides 32 and 10?
It doesn't matter. This is going to have to be the same. That's something you should learn before this class. Every single number has a unique prime factorization. I don't care what I pick to begin with. It's all going to have to end up at 5 2's here, and then a 5 times a 2. It's got to have 6 2's and 1 5. Right? There's no other way to do 320. It's got to end up here. So we said that a 2 comes out and the 10 is left in. How do you do the variables?
5 A's. 5 A's and then 1 A's left.
Yeah, 5 goes into 6 once with 1 left. 5 goes into 14 twice with 4 left, and 5 goes into 4. No, so it's all left. 4 little dudes.
Confused on
What
where all the
is
2's
in there?
went.
5 2's and 10.
All right, so let me
okay.
take a step back.
Like, I just don't know how to set it up. Oh wait, I see it. It's on the outside.
Square root of 49 is, what happened to the 7s? Well, square root cuts it in half. Fifth root cuts this in fifths. So the fifth root of 5 2's is 2.
It's 2, so it gets on the outside.
Yeah. Every group of 5 2's I see has a 2 come out. I don't want. So how could I? Let me focus on this by itself. Let me actually show you a slightly different way. Once you get here, 2 to the what? How many 2's do I have total here? 6. Times a 5. 5 goes into 6 once with 1 left over. 5 doesn't go into 1, so that's left over also. There, 2 on the outside, 10 on the inside. So you can look at it either way. 2 on the outside, 10 on the inside. You can stop right here. Fifth root of 32 is 2. Why? It takes 5 2's to multiply to be 32. So don't, and Jesse, I'm not saying you can't think this, but don't let yourself say what happened to all the other 2's. We have no problem with a 7 went away here. We don't even think about it like that. We're like, the square root of 49 is 7 because it takes 2 of them to make 49. The fifth root of this is 2 because it takes 5 of them to make this.
Makes sense. I see it.
Okay, okay. No, I'm not, well, now I can see out of the corner of my eye other people going. All right.
No, that makes sense. I just didn't see them bring it out.
Okay, hopeful. And one good point that was brought up earlier, I don't know if you've noticed this, but if one of them is going to be harder, I try to make the practice test more difficult, to tell you honestly. And very often, like, I'm probably not going to give you a number like 320, but I like to give you more difficult stuff on the practice test because then we can talk about it in here, and then the easier ones should be a little easier. Should be. Okay. All right. Any other questions on? So we can do examples. You guys can.
Can we go to 6.5?
You can do the quiz corrections, right? Quiz corrections are due on Monday. What's up?
6.5. Go back there.
Yeah.
Number 28, I guess.
Number 28.
I think it was, or 31. Or 21, yeah, it was one of those two.
All right, I'll do 28.
What I did is I got the 2t plus 15 on the other side. But I tried to figure out what goes into both of them, but I couldn't figure it out.
Okay, this one here.
Yeah.
So guys, what part of this problem tells you what to do first?
It's not either or, right?
Yeah, this square here, higher power in the t tells you to get it equal to 0. So what do I do with these pieces? Keep my t squared positive. So subtract these suckers over here. So I'm left with 0 on that side. And over here I get t squared minus 2t minus 15.
That's as far as I get.
Oh, you can do this now.
Well, I just can't figure out what, like.
Only one way to really factor 15. It's not 15 and 1. It's never going to make 2. What's the other way to factor 15?
3 plus 5.
And which one's got to be negative to make 2 negative?
3.
The bigger one.
Or 5, okay.
Right? When they're different signs, the bigger one tells you the sign of the answer.
Okay. Bigger one says 8. Okay.
So now you can finish that out. Cool. Yeah.
I'm still kind of stuck on this root thing.
So which one?
So like for 3b, since 27 is a cube,
Yep.
would I just take the 3 out, or does 3 stay on the inside?
What is the cube root of 27?
3.
3. Good.
So is that on the outside
So-
or the inside?
I see this a lot, and let me show you hopefully something that's going to stop it. If I said 5 squared, what's that?
25?
If you wrote that, is that right?
No.
Why is this should not be there anymore? Because it's been done.
Yeah.
So the cube root of 27 is 3. If you wrote this, same mistake.
So
I've already done the root. It shouldn't be there anymore.
And then,
Does that make sense?
yeah, but then for the variables, like 3 goes into 6 twice, so would you just have x squared on the outside or something?
Yeah. Yeah. So,
And then y to the third or something? And
yeah,
that's
3 goes into 6 twice. 3 goes into 9 3 times.
And,
And again-
nothing left on the inside because it all works out.
Again, why is the cube root of 27 3? Why exactly?
It's 3 times 3 times
Because
3.
3 times 3 times 3. Why is the cube root of x 6 x squared? Because x squared, x squared, x squared. Same reasoning.
Yeah.
But these give me a shortcut because of the way they're written. They're written in very compact, nice form.
Yeah.
So the fact they're written like this tells me I have a shortcut. 3 goes into 6 twice.
Can we do a practice one where there's like stuff left over or like a bigger one? 'Cause
Yeah.
I don't know.
Like the one we did earlier?
Yeah, like breaking it down is hard.
Alright, let's see. So again, when in doubt about a number, and you see this a lot in mathematics, you do the numbers first, and then you do the variables as they come, because very often they don't act the same way. One is a number, and one's written as a variable with powers maybe. They're not going to act the same way. That's why we do it that way. So let me first focus on that 162. When in doubt, you start to do what?
Break it down.
Panic? No.
Yes.
Well, yes, you do, but that's all right.
So now would you break it down into like 4 times
Doesn't
4
matter.
times 2 or something?
No, because that's not how you break it down. But
That's why I'm confused.
you
'Cause
start to
4
really
is
break it
16,
down.
right?
Two and two.
Or no, you don't do it that way?
It's not 16 and 2.
I know.
It's 162.
So now
So
what?
4 does not go into 162.
Two and two.
So 2 times 81. It's even. That's not a bad place to start, right? Divided by 2, you get 81. And the nice thing about 81, it's 9 times 9, and each 9 has,
Yeah. How do you...
what's up?
She's confused at like how do you get the 81 and the 2? You just think like it just
So
comes
it's way
together,
back
like,
to
okay,
learning
that's
prime factor trees. That's all I'm doing.
Just become-
What's the good first number to use if it's even? Divide it by 2.
Okay.
If it's not even, you divide it by 3 or something else. You try something until you get something that works, right? And then you keep breaking them down if they can go further. So here it's even. So I'm going to divide it by 2 and I get 81. So the 2 is done. You put a little circle on it, remember that or whatever? 81 can get broken down into 9 and 9.